All right, guys, so moving along with the Chevelle Turbo LS build, today we're going to be installing the crankshaft and new main bearings in the bearer block. Now, the stock crank was sent out to the machine shop. It just got polished up. It's a perfectly good crank to use for this build, and the main bearings obviously will go with new ones. All right, so a huge thanks to today's video sponsors. Summit Racing supplied the bearings and the plastic gauge, and Eastwood delivered on all the torque wrenches. These torque wrenches are a huge upgrade from what I've been using in the past. So I'll leave links to everything used in this video in the video description and in the iCards in the upper right. Okay, so here's the stock crank that came out of the motor. It came back from the machine shop, and all I had them do is mic it, inspect it, clean it, and polish all the journals, okay? So this thing's ready to go. And the cost to do that, I think, was like 70 bucks. So all the journals are nice and clean, polished. And what I'll probably do is hit this with solvent and brake clean and give it a really good cleaning prior to assembly. Okay, here's just a better look. You can see they really did a nice job cleaning up the journals. They're really smooth. And yeah, it's ready to go, ready to install. Okay, for the main bearings, we're going to be using Sealed Power part number 7298 MA. Okay, so these are all new main bearings. I already unpackaged these, that's why they're all kind of loose in here, so I'm going to be careful with them. So this oddball one here is the thrust, and then here are the other main bearings. Jeez, I'm being rough with these. Alright, so here are all the shells. And what I'll do is I'll hit these with brake clean to make sure all the packaging dust is off of them. And I'll blow dry them with compressed air, and then we can install them. Okay, let's start at the front of the block. This is position 1. All this here has been cleaned, dried out. So this has been hit with brake clean and obviously compressed air, so these surfaces are completely smooth. Notice there's a tang here which will go right here. Okay, so what you do is you just kind of put the bearings in. Okay, just push them in. And obviously you're going to want these flush, or as flush as possible. So the tang goes here, flush here, and notice how these bottom shells have the holes in it. So this is where the oil comes in and feeds the mains and the rods. Okay, let's do the next shell. Snap that guy in. Here is the third position, which is the thrust. So this is the weird looking one with the flanges here. And that keeps the crank fore and aft position. Okay, so just go ahead and put that guy in there. Here's position 4. And position 5. Alright, so now we can drop our crank in. Okay, time to drop in the crank. Do it real carefully, do it very slowly. And I have the snout and the tail end here grabbed, and I'm just gonna slowly guide it in. Okay, and one thing to note is at the 12 o'clock positions here, there are no oil holes. So that way, when we lay down the plastic gauge, that's ideal, right? You don't want it going over an oil hole. One more thing, even though I got this crank polished at the machine shop, and I got it back, and you know they supposedly cleaned it and everything, I took an additional 20 minutes or so and scrubbed this thing in my solvent tank. I use a Stoddard solvent. Basically, I just went over it with a brush, and there was some dirt on it, okay? So you want to make sure it is fully clean, even though the machine shop said they cleaned it. And also, I made sure all the holes, all the oiling holes, flowed good solvent, and I blew everything dry with compressed air, okay? So now what we're going to do is set up our plastic gauge, put our other shells in our main caps, and check our bearing clearances, okay? Okay, so what I have here are the main caps. I got 1, 2, 3. This is the thrust, 4, and 5. Okay, 1 through 4, the wings face the back, and on number 5, the wings face front, right? Just like how we did with the disassembly. Okay, so I solvent cleaned all these caps, and you're going to want to make sure this is clean. Okay, I also cleaned the shells. Okay, so they are completely clean. Okay, what works pretty good is newspaper. You just kind of run it here to get all the stuff clean. There's no lint on there. Okay, we got our tab here and our notch, so go ahead and roll the bearings in. Okay, so we got that on there. Okay, I believe GM recommends, or they don't specify whether to put oil on the threads or not, but since we are torquing these to an angle, it doesn't matter. I think it doesn't matter because, I mean, if you think about it, there is a difference between dry and a wet torque when you achieve a certain foot-pound range, but since we're going by angle, it doesn't really matter. But in any case, to help the threads out a little bit, I'll just put a dab of oil. Okay, so just go ahead and repeat that procedure for all the main caps. The tang is towards me on this side. Okay, this one here is our thrust. Okay, and just do that to the other two as well. Okay, so what we're going to do now is use some plastic gauge. This is the 1 thou to 3 thou inch range, and you can buy these at Summit Racing. And basically what this is if you open this up, see this green string here? It has a certain diameter right now, and as it compresses, it flattens out to a certain width. And the less clearance, the wider the width it'll be. So basically, we'll lay this down in here, torque everything, and then here are our widths. So both the white and the green spaces here are equivalent to a width and a clearance. So the widest one here is 1/1000, then the white one here is 1.5 thou, this green 2 thou and 3 thou. So see, as the clearance increases, the width decreases. Okay, so what you want to do is just measure a good amount of width here and snip it with some scissors. Okay, and just lay it right there. Now this stuff will it's kind of tricky. You know, a puff of air and it'll blow away, okay? So you're going to be very careful. And in the past, I've even used a little dab of grease on one end to keep it glued in place for this process, okay? Okay, so here's my number 1 bearing cap. I got a little bit of oil on the bolts. The bearing shell is clean and dry, and the wings face the back. Okay, so that cap is all the way down, and I can see the plastic gauge is still there in the 12 o'clock position. So we'll move on to the next one. Okay, what has helped me in the past is some tweezers. There you go. So just lay that in there, and that's going to be especially important for this one over here where the crank webs are kind of, it's a really deep way to go. All right, so we'll lay this down in here. Just try to get it parallel to the axis of the crank. Okay, so this is the number 3 with the thrust bearing. Go ahead and drop it down. Alright, so here's where the tweezers help out on a journal like this when you got the webs really tall. Alright, so that guy's laying in there nicely. Got our number 4 cap here. Alright, with this one it's going to be hard to hit with a hammer because the web's here, so I'll just rely on tightening these bolts up little by little on each side. So we'll just move on to number 5 here. Okay, that looks good there. Okay, here's number 5. Notice the wings face the opposite way of all the rest. So this is the oddball cap. Okay, now I'm just going to run these in real slow with the impact. Just hand tight, if you will, okay? Okay, so there's a special torque sequence and pattern for LS motors. So first you got to do the inner bolts at 15 foot-pounds. Okay, that's pass 1. Pass 2 is you take these same bolts and add 80 degrees of swing. Then the outer bolts go to 15 foot-pounds. Okay, that's pass 1 on those. And then for the final pass you take these to an additional 51 degrees of rotation. And the sequence goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And I'll put a screenshot of the sequence so that way you can pause the video and print it or whatever so you have that information. Summit Racing has all the torque specs for the entire LS motor family up on their website, so I'll make sure to post the link in the video description below. Okay, so another company that's helping me out is Eastwood. They sent me like 4 different torque wrenches for this project, and this one just happens to fall with 15 foot-pounds in the middle of the range of this 3/8 torque wrench. Okay, so that's kind of what you want to do. You want to use a torque wrench that has the value that you need pretty much in the middle of the range. Okay, so number 1, that's 15. It's 15. Okay, this bearing cap wasn't walked all the way down, so I'm going to jump back and forth here because I couldn't get a hammer on it. So I'm just going to go back and forth here until it's fully seated. Okay, it looks like it's fully seated, so I'll go ahead and torque this. Okay, this is 5 over here. 6. 7, 8, 9, 10. All right, so all those have done the first pass on the inner bolts. Now we got to take an additional 80 degrees. All right, so I picked up one of these cheap tools. This is for angle rotation. Okay, so you basically have this as a stop. You zero it out, and then you can go your 80 degrees, all right? Okay, so I have it tight up against here. I have it zeroed out. I'm just gonna put a breaker bar on it and go 80 degrees. All right, so let's see where we're at. 30, 40, 50, 60, 70, 80, all right. Okay, this tool isn't working so well. So what I have here is a digital angle measuring device, and what I'm going to do is just eyeball the starting and end angles. Okay, that actually worked pretty good. Okay, we did those two. All right, so the inners are done. Okay, so 15 foot-pounds on the outer, same sequence. So we have 15 there, 15. Okay, now we're going 51 degrees. Okay, so all those are torqued, and it's actually pretty easy to eyeball the angle, to be honest. Okay, I'm also going to put in the side main bolts. Okay, I don't think that really affects the clearance rating. However, why not do it, right? Let's get a couple extra minutes. So we'll just put these in and torque them to 18 foot-pounds. And here's the next size of the Eastwood torque wrench, which is really nice. So I have two different torque wrenches set up for two different specs, so that's kind of cool. Okay, now we can take it all apart. Side bolts I'll rip out with the impact. These I will loosen by hand first and then impact. All right, we could come in here and just try to wiggle this guy off. All right, so I just cut a little piece of the plastic gauge off, and you can see, let's see if we're at 1 thou. No, it's narrower than 1 thou. So we have more than 1 thou of clearance. And you can see 1.5 thou. It's looking pretty close to 1.5 thou, but it's actually, so we have a little under 1.5 thou clearance. All right, so we don't quite have 1, but we don't have 1.5 thou, so we have slightly under. Okay, so production tolerances for the mains are 0.008 thousandths of an inch, so that's under 1 thou, okay? Up to 2.5 thou, okay? And we're sitting at about 1.5 thou, maybe slightly less. Okay, if I take a closer look at this, in some spots it's right on the money at 1.5 thou, and in some cases it's a little wider, so that means The clearance is slightly under 1 thou and a half, but we're definitely over 1/1000th of an inch. So to me, that's good. So let's move on to the next cap. Okay, this isn't really coming up on camera all that well, but let me just tell you what it is. Alright, so we're definitely narrower than 1 thou, and this one is right at 1 thou and a half. Nice and even all the way across. That's what I'm calling it. Okay, these aren't really coming up on the camera, guys. I apologize for that. Definitely more than 1 thou. Yeah, we're right at 1 thou and a half. In some spots it's a little narrower. But I'm going to call this one 1 thou and a half as well. Okay, this one's really hard to get in here. So I've got my tweezers here. Definitely more than 1 thou. I'm like right at 1 thou and a half actually. Yeah, that's looking really good. I'm calling that 1 thou and a half. Okay, last cap. We're doing awesome so far. Alrighty, number 5. So we have more than 1 thou. Looks like 1 thou and a half, maybe slightly larger in some spots. Over here we have 1 thou and a half. There's a little bit of a taper, but definitely less than 2. So I'm just going to call it 1 thou and a half. I mean, that's the average across there. So awesome. 1 thou and a half on all 5 journals. So that's good. Can't ask for better than that. Okay, so what we're going to do now is remove the crank. I'm going to put it on the workbench and I'm going to clean all the Plastigauge off, both on this and the top half of the shells, okay? With a little bit of brake clean. Then we're going to put assembly lube in the bottom shells and we get to assemble it all back together. We're going to set the thrust, because we didn't do that with the Plastigauge because you don't want to move or rotate the crank while you're doing Plastigauge. And then we will retorque everything, seal up the side bolts because I'm planning on reusing them, and then we should be done. All right, so let's go ahead and lift this guy out. Be careful. All right, a little bit of this Permatex Ultra Slick Engine Assembly Lube. So go ahead and put a little bit of this on all the bearings. Okay, we'll put some on the cam too, why not? Alright, so just go ahead and smear some on. You just need a thin layer. Okay, make sure you get your thrust. Okay, so the sides of this bearing will do the thrust, alright? So make sure you put a lot of lube on there. Okay, we'll drop the crank in. Alright, rotate it. Should be nice and smooth, and it is. By the way, brake clean worked great for removing the Plastigauge. A little bit of squirt, let it soak for 20 seconds, and it wipes right off. What we'll do is we'll put a little bit of lube on our bearings here on the other side. Okay, so we got a little bit of lube there. Okay, 15 foot-pounds. Same torque sequence. Just the inners for now. Okay, all the outer ones are loose. Okay, so we just torqued the inner ones to 15 foot-pounds per the sequence. Okay, now with just the inners torqued to 15 foot-pounds, we need to set the thrust bearing. And how you do that is you hit the crank with the rubber mallet in the front to shift the crank back, and then you go to the back and hit it to move it forward. And you always want to end it within in the forward position, okay, before moving forward. So we'll just give it a couple good whacks to set it in the backwards position. Okay, now forward. Okay, now we can proceed with tighten these inners another 80 degrees. Okay, so we did our pass for 80 degrees on the inners. Now we're going to torque the outers to 15 foot-pounds. All right, for the outers, 51 degrees. All right, so all those are torqued, spinning the crank real nice. Let's set up a dial indicator and measure our thrust clearance now. Now we're going to inspect how much thrust clearance we have, or crank end plate. So what I have here is a dial indicator with a magnetic base, and we'll just stick it right on here. Turn it on. There you go. It's magnetic, right? So you want to have the dial indicator parallel to the axis of the crankshaft. You want to have a decent amount of preload on here. And let's just go ahead and discuss what we're going to do. Okay, so what I'm going to do is I am going to force the crank one way with the screwdriver, zero out the gauge, and then we will move it the other way with the screwdriver and see how much it deviates from zero, and that is our end plate, okay? So I'm gonna just decide to put a screwdriver in here against the web of the crank and the main bolt, or the cap, okay? And you can see that the dial indicator is moving, so I'll go ahead and zero it out. And I'll do this procedure with the dial indicator better in view, but okay, so I'm gonna zero the guy out. Okay, so that's zero. Now I'm going to go the other way with the crank and measure my end plate, and I am at 3 thousandths. So let me go ahead and zoom in on the dial, and then I will be doing that trick with the screwdriver, okay? Okay, that's zero. Now I'm going to take the screwdriver out, see how it relaxes a little bit. Now I'm going to go the other way. So you can see I have 1, 2, 3, just a little over 3 thou end plate. So 0 to 3. 0 to 3 as I walk the crank back and forth. Now I also have a little bit of assembly lube on there, and that adds a little thickness, okay? So take that information and, just keep that in mind. Okay, so the spec for thrust on an LS motor is 0.0015 thousandths to 0.0078 thousandths. So you can see we're at 3 thousandths, which is perfect, okay? Now, if you need more thrust clearance, then Summit Racing has a good video on how to take out that bearing, this number 3 bearing, and you basically sand the thrust surface to make the bearing thinner, therefore increasing thrust clearance. Okay, so I'm not going to do that in this video. I don't need to, but I'll definitely throw up a link in the iCard in the upper right and in the video description. So we're all good. Thrust is good. Okay, now to install the side bolts, and there's no torque procedure or sequence other than bring it up to 18 foot-pounds. Now I will be reusing my bolts. I just cleaned them up. The factory ones have some sealer applied to the bolts, so if you're using new ones, no issues, just run them in. If you're using used ones, you're going to want to apply a little bit of RTV around the thread bolt, all right, and on the head of the under the head of the bolt. Okay, so I got a little bit of sealer. Go ahead and run that in. All right, 18 foot-pounds. Okay, all the bolts are in. Everything's lubed up. Our clearances look great everywhere. Crank spins super smoothly. And this job is done. Now we can move on. All right, guys, that's it for this video. In the next video, we are going to be file fitting rings, setting up the ring gap correctly with a lot of boost.